If you want to know how to factorize quadratic equation with more than one variable, then I want you to stick to the end of this video, because in this video I'm going to be showing you that in detail. Hi, AC Okocha is my name, and this is Just Academic Mathematics, where we make you a mathematics genius. This is a sequel in our quadratic equation series. We are still in quadratic equation, and we are specifically in factorization of quadratic equation and expression. So today I'm going to show you how to factorization of quadratic expression with more than one variable. And this is part 1 of it, part 1. I'm going to show you the part 2. Okay, now this type of factorization is quite simple, but not all of them. Some are complex anyway, but I'm going to show you all that you need to know. So when you have this type of factorization involving more than one variable, if you look at this is variable x now, this is y, this is a. So you have different variables. It's not like the one we did before where it's just one variable. Now if you want to factorize this, in most cases, use what is called grouping. You group them. You know what we did in our last class. For instance, we have 1, 2, 3, 4 different quantities. We can group them in pairs. That is 1, 2, and 1, 2. That may not work. You may need to rearrange, but I'm just giving you an idea of what to do. So if we try to solve it as it is now, that is this pair, then this last pair. If that works, fine. If that do not work, then we may need to rearrange. We may need to combine this and this, or this and this. But let's see. So if we consider it as it is now, in this pair, nothing is common, so 1 will come out. In this pair, minus a is common, so if minus a is out, it will remain s plus y. So that will work, because that will help us to have the same bracket. This is what I mean. So we have x plus y minus ax minus ay. Now, since nothing is common in this first pair, we say that 1 is common, which is s plus 1 inside. Then inside this last pair, what is common? It is minus a. So if minus a is outside, what will remain? It will remain x. Here has to be plus y. Why is it plus? Because minus times plus will give you minus. Minus times plus will give you minus. So always check it. It must give you back what you have here. Minus a times s minus as minus a times plus y minus ay. Are you following? So since the bracket is the same, you know what to do. We factorize. We factor out the common bracket. What is common now is x plus y. And what will remain if we do that? It will remain 1 minus what? A. So this is the factorization of this equation. So as you can see, it's very simple. So that is what is expected of you here. Now, our example 2 now. Let's see our example 2. So for example 2, we have this. We are asked to factorize this now. Now the first thing you are expected to do here in this example 2 is to consider the two brackets. Are they the same? As they are arranged now, they are not the same. 2a minus b is not the same thing as b minus 2a. So these two brackets are not the same. Assuming they are the same, we will have just factored out one of them. But since they are not the same, we need to go ahead and open the brackets. So this is what we have. M bracket 2a minus b minus 2n bracket b minus 2a. So let's expand. We open the bracket. M times 2a will give us what? 2am alphabetically. Then m times minus b minus bm minus 2n times b minus 2bn minus 2n times minus 2a will give us what? Plus 4an. Are you there? Now that we have done that, we need to rearrange because this pair and this pair do not work. Why don't we take, here there is 2a and here there is 4a. We can take this and this. That is 2am followed by what? Plus 4an. Then minus bm minus 2bn. So in this first pair now, what is common? Obviously, 2a is outside. What will remain inside? It will remain m plus 2n. Always check if it will give you back. 2a times m, 2am. 2a times 2n will give us 4an. Now in this second pair, what is common? Minus b is common. And what will remain? It will remain m plus 2n. Check. Minus b times m minus bm minus b times plus 2n minus 2bn. So it's correct. Notice that the two brackets are now the same, unlike this one here. The two brackets are the same. Since the two brackets are the same, we factor out one of them, which is m plus 2n. If m plus 2n is outside, what will remain here? It will remain 2a. What will remain here? It will remain b minus b. So this is the answer. But please, anyone can come first anyway. It's because if you factor, notice that 2a is starting first. So we can start with 2a minus b times m plus 2n. They are the same thing. And that should be option C. So you solve it to tally with what you have in the option, the arrangement in the option. So the option, this bracket comes before this bracket. You see the same thing. Assuming I was looking at it, I would have factored in this, bring out these ones. But it's the same thing. So that is it for number 3. Example 2. Now that brings us to example 3. That brings us to example 3. So we have example 3 here. Look at example 3. Now for example 3, we are asked to factorize completely. You can see what we want to factorize. So there are different tricks. You don't always expect the same thing. Now if you look at this, remember what I told you. You can see this one has square. This other one does not have square. Grouping is still the best approach. Grouping, that is the best approach. So if you look at this now, since we have 1, 2, 3, 4, we can group them in pairs. So let's consider grouping it the way it is now. That is these two, one group, these two, one group, and see if that will work. Let's see. So we have 4abx minus 2axy minus 12b squared x plus 6bxy. So in this first pair, what is common? 2ax is common. 2ax is common between these two. So if 2ax is outside, what will remain? Of course, since 2 is out, 2 will still remain here. A is out, S is out, then B, that is 2B. 2as is out, so what will remain here is minus y. Can you see that now? So we do the same thing here. If you consider this between 12 and 6, 6 is common. Since here is minus, that is minus, 6 is outside. Then we have b here, we have b here, we have x. So bx is also common. Bx is common. So 6bs is common. And what will remain? Since 6 is out, 2 will remain here because 6 times 2 is 12. Then 1b is out. B square is there, so b is here. X is already out. Then here will be minus 6bs is out. y will remain. Can you see that? If you open the bracket with this, you will get back to this. Minus 6bs times 2b will give you minus 12b squared x. Minus 6bs times minus y will give you plus 6b xy. Now notice that the two brackets are the same, which is an indicator that your factorization is correct. So if you factor out the common bracket, but you can bring out the common bracket first, or you can pick these two in front first. Let's pick these two in front first, which is 2ax, then minus 6bs. Then we'll pick one of the common brackets, 2b minus y. It's still the same thing. We'll factor out the common bracket here. If you bring out this common bracket here, what will remain is this and this. Look at them here. Now, if you consider these two, notice that something is still common. And what is it? 2x. So if I bring 2s outside, what will remain here? It will remain just a minus what? 3b. Because 2s times a will give you 2as. 2s times minus 3b will give you minus 6bs. Then times 2b minus y. So this is what we should look out for. And that is option, I guess it's option A. If I'm not mistaken, that is option A. Option A. Yes, it's option A. That is option A. So that is for this number 3. Now let's proceed. Look at our number 4. Look at our number 4. Interesting. So number 4, unlike the number 3 and 2, if you look at number 4, you notice that we have just 1, 2, 3 values. And these two has square. So we can actually factorize this the way we factorized in our last class with one variable. So what we need to do is that we need to look for a way to duplicate this one at the center. If we duplicate this one at the center, then we'll now have 4. Then we can group them in pairs. So how do you know what to use to duplicate this one? Because, for instance, ay plus ay is 2ay. And 3ay minus ay is also 2ay. How do you know the combination to use that will work in this factorization? Simple. You add what you will add to give you 2 times to give you 15, minus 15. And minus 15, the factors of minus 15 is, among others, include 1, 3, 5, 15. You know what I'm talking about. So you look for, I taught you that in our last class, 2 numbers you add to give you 2 times to give you AC, which is what? Minus 15. And of course, the 2 numbers will be what? Will be 5 minus 3. That should be the 2 number. 5 minus 3 is minus 2. 5 times minus 3 is minus 15. So we'll use this 5 minus 3 to replace this one at the center. So this is what we'll have now. 5y squared plus, in the place of this 2ay, we'll replace with it 5ay minus 3ay, then minus 3a squared. So this one now is still the same thing as this 2. 5 minus 3 will give you 2. This is this. This is this. But with this now, we can group them. These 2, this first 2, this last 2. So in this first 2, what is common? 5y can come outside. And what will remain? It will remain y plus what? A. Are you seeing it now? Then in this last 2, what is common? Minus 3a can come outside. What will remain? Y plus what? A. Can you see that now? So if we factor out this y, what is common, which is y plus a, if we bring it out, what will remain is what? It will remain 5y minus 3a times in what we brought out, which is y plus a. Are you following? It's still the same thing. I was looking at this was, okay, because we have already gotten the answer now. Look at the answer here, D. But from here now, let me repeat that. Here, what is common now is these two brackets. So bring it out, a plus y. And what will remain? 5y minus 3a. When you do that, it's still the same thing. So anytime you are factorizing, always keep your eyes on the option. If in the option, if there are options, but if there are no option, what if another person that presents his own answer, let's assume there is no option, and someone leave his own answer like this. Is the person correct? Yes, 100% correct. 100% correct. Any of them can start. I get what I'm saying? Because the reason why it's like this is it depends on what you decide to factor out first. Someone can decide to start with minus 3 plus 5. Actually, normally I would have preferred to start with minus 3 plus 5. That did not occur to me. That is according to their size. Minus 3 plus 5. If we have started with minus 3 plus 5, it will be easy to, but it's still the same thing anyway. So let's not waste time with that. Look, that brings us to number 5. Number 5, example 5. Now, if you look at this example 5 carefully, you will notice, don't always rush to open bracket. I've been saying that. Some you need to open bracket, but not in most cases you may not really need to open bracket. If you look at this carefully, you notice that these two brackets are the same. A plus B, A plus B. So that makes it easy for you. You get what I'm saying? So in that case, you can just replace, you can say let P be equals to A plus B. Then by doing so, you are now having 12p squared minus 15 minus 24p. So it's now a simple quadratic to factorize. Are you getting it now? So if you rewrite it, it will give you 12p squared minus 24p minus 15. So what we need to do now is, you know the rule now of factorization. We look for two numbers we'll add to give us 24. Let me exhibit it here. So we look for two numbers. Those two numbers, we'll add them together to give us minus 24. And the same two numbers, if we times them, it will give us 12 times 15. 12 times minus 15, which is what? Minus 180. So how do you know the two numbers? I've taught you that. I'm not supposed to be doing this. I've shown you this before. We have done this in our last class. So you go and express 180 as a product of each prime factor. This is what I mean. 180, 2 can go here, will give us 90. 2 go into 90, will give us 45. 3 can go. 3 go into 4 is 1. Remember, 1 into 15 is 5. 3 will see go 5. 5 go 1. So let's look for a way to merge this such that when we add, we'll merge it into 2. So that when we add, we'll get 26, 24 minus 24 and minus 180. So if we try 2 times 2, 4, 4 times 3, 12. Can 12 and 25, 15 give us 24? No. Why don't we try this? This is 6. Why this one? This is 2 times 3. 6. 6 times 5, 30. That will give us 24. Because 30 minus 6 is 24. As a matter of fact, the two numbers we are looking for are minus 30 and 6. Minus 30 plus 6 is minus 24. Minus 30 times 6 is minus 180. You should know how to do this. We have done that. So we'll replace this 24 here with these two factors. So here we now have 12p squared. In the place of 24, we'll write minus 30p plus 6p minus 15. So we'll factorize in pairs. In this first pair, what is common? 6p is outside. If 6p is out, what will remain? To remain 2p. And what will remain here? To remain minus 5. Because this time this will give you this. And 6p times 5 minus 5 will give us minus 30p. Here, what is common? Of course, plus 3 will be out. If 3 is outside, what will remain? It will remain 2p minus 5. Now, if you remove this one that are common, if you factor it out, 2p minus 5 outside, what will remain here? It will remain 6p. What will remain here? It will remain plus 3. Are you there now? So, we can as well now notice that 3 is also common here. So, if 3 is outside, what will remain? It will remain 2p plus what? Plus 1. Because this time this is 6p, this time this is 3, times 2p minus what? 5. It is at this stage that we will now recall that what? That p is equals to a plus b. So anywhere we see p, we replace it with a plus b. So we have 3 times 2p, a plus b plus 1, bracket 2 times a plus b minus 5. So we'll expand to get the final answer. We'll get that 3 bracket 2a plus 2b plus 1 bracket 2a plus 2b minus 5. So this is the final answer. It's final answer. You say you can still use the other type of bracket. It's the same thing. So this is the factorization of this. The expansion of this now will give us this back. You get what I'm saying? The final example for this one, class, make sure you see the next class. Example 6. Now, look at what we have here. If you look at this question critically, carefully, you will see, don't always rush to open brackets, because opening brackets may make the question to be more cumbersome or more complex. So what you will need to do is always check if there is anything common. If you notice this bracket, you will see 3a squared minus 2a. But notice that inside this bracket, there is a place we have something similar to this. 3a squared plus 2a. This is minus 2a. This plus 2a. So the first goal is to write this one to look like this one. This is what I mean. So we have 5 minus 3a squared minus 2a bracket 6. You see this place here? Let's bring this minus out. If this minus is out, this bracket will now be what? 3a squared minus 2a. Then this bigger bracket. Or let me differentiate it with this. Now, look at this. Look at this. Minus times 3a will give you minus 3a squared will give you minus 3a squared. Minus times plus. So rather, minus times minus will give you plus. So this and this is still the same thing. But we have succeeded in isolating, making these two to look alike. And in making these two to look alike, it will now be easier for us to do what? For us to factorize this. By saying what? We can come and say, let P be equals to 3a squared minus 2a. So for us to see it clearer, because if I should factorize it like this, you may not understand what will happen. So that we'll now get 5 minus p times 6 minus p. Can you see something now? So we are now having 5 minus 6p minus p square. So you can see that this is a pure quadratic now. We factorize it. Add to give us 6. Time to give us AC. AC is what? Minus 5. Minus 5 and minus 6 will give us minus 5 minus 1. Minus 5 minus 1 is minus 6. Minus 5 times minus 1 is plus 5. No. Add to give us 6. No, that will 5 and 1 will not work. 3. Minus 3 minus 2. No. Minus 3 minus 2 is add to give us 6 times to give us minus 1. No. There is a mistake. This time this is plus. Minus times minus here is plus. So let's take it again. You add to give us minus 6 times to give us, okay, 5 and 1 will work now. Minus 5 minus 1. Yes. Minus 5 minus 1. Minus 5 minus 1 is minus 6. Minus 5 times minus 1 will give us plus 5. So here is 5 minus 5p minus p plus p square. So this and this is the minus 6. This is this, this is this. So factorize in pair. What is common now? 5 is outside. What will remain? 1 minus p. What is common here? Minus p is outside. What will remain? 1 minus p. Of course, minus p times 1 minus p. Minus p times minus p plus p square. So if p is common, if you pick the one that is common, which is 1 minus p, what is remaining? It will remain 5 minus what? P. So you can now quietly recall that p is equals to 3a squared minus 2a. Even that one, something can come out anyway. But let's substitute first. We have 1 minus bracket 3a squared minus 2a. Then we have 5 minus bracket 3a squared minus 2a. So let's expand. So we have 1 minus 3a squared plus 2a. Then here we have 5 minus 3a squared plus 2a if you open the brackets. So we can factorize this again. This is another factorization. Let's see both of them can be factorized. So this is a, not 29, please. So we add, remember, because of space, but let me rewrite it. If I rewrite it, I have minus 3a squared plus 2a plus 1. Then we have minus 3a squared plus 2a plus 5. So let's factorize now. We'll look for what we'll add to give us 2 times to give us minus 3. What is it? Add to give us 2 times to give us minus 3. That should be plus 3 minus 1. Plus 3 minus 1 will work. So we have minus 3a squared plus 3a minus a plus 1. That is for this. This will give us this 2. Then we can factorize in pairs. Then the same thing here. What do we add to give us 2 times to give us minus 15? 15, let's check 5 and 3. Add to give us, what about 5 minus 3? 5 minus 3 is 2. 5 times minus 3 is minus 15. That should work. Minus 3a squared plus 5a minus, I will have started with minus 3a, but it's still the same thing. Minus 3a plus 5. So what is common now? I'm trying to squeeze it in. What is common here is minus 3a. What will remain here is what? A minus 1. What is common here is minus 1. What will remain here is what? A minus 1. That is for this first bracket. Then for this second bracket, what is common here is minus a. What will remain here is what? 3a minus 5. What is common here is minus 1. What will remain here is 3a minus 5. So therefore, we conclude, if you pick what is common here, which is a minus 1, what will remain? It will remain minus 3a minus 1, which you can bring 1 minus out anyway. Bracket, what is common here is 3a minus 5. What will remain is what? Minus a minus 1. Are you with me now? So if you bring out this minus outside, and bring out this minus outside, the two minus will interact with each other to give you plus. Because we can bring out this minus. If you bring out this minus outside, here will be 3a plus 1. If you bring out this minus outside, here will be a plus 1. The minus times the minus will give you plus. So the final answer will be a minus 1 bracket a plus 1, if I should start with this, bracket 3a plus 1, then 3a minus 5. That is the answer. That is the final answer. If you expand this, that is what it will give to you. I hope you know nothing has changed. This one is this. This one here, minus out. When you bring minus out, you have a plus 1. But why is the minus not reflecting here? Because this one, if you bring minus out also, you have 3a plus 1. The minus that is out here plus the minus times the minus that is out here will give you plus. So that is why this one is positive and this one is positive, then this is this. So this is the answer. That is the answer. There are more complex ones I'm going to be showing you in our next class. So you make sure that you see the next class. And if you need a one-on-one class, don't hesitate to reach out to me via the WhatsApp contact showing. And make sure you follow us on all our social media platforms. Thank you.